Hello and welcome to the part 4 of ABG discussion. We were discussing about the graphical representation of six metabolic and respiratory disorders. Right, so this becomes metabolic acidosis because pH is decreasing and PCO2 is decreasing. This becomes metabolic alkalosis. Now this is chronic respiratory acidosis because the play in pH is less in this region as compared to this, because here the pH is changed. Now body has compensated and maintained the pH here, so that becomes a chronic process in this, and this becomes chronic respiratory alkalosis, and this is acute respiratory acidosis because pH has gone down and PCO2 has gone up. Right, so let us see how the body needs to compensate. We need to remember that the ratio of bicarb and carbon dioxide. Okay, so in case of metabolic acidosis, the bicarb goes low, right? For every single unit drop in bicarb, the PCO2 should drop by a single unit. Now that we have to remember. Okay, so if somebody's bicarb was 24 and it has come down to 20, right? So how much should the PCO2 drop? So that's about 6 units, right? 4 units, I'm sorry. So PCO2 should come down from 40 to 36. That would be metabolic acidosis. Okay, so that's for metabolic acidosis. Now coming to metabolic alkalosis, bicarb goes up. So for every 2 units increase in bicarb, PCO2 should go up by 1 unit. So that means if you have gone up from 24 to 26, that's 2 unit increase, the PCO2 should go from 40 to 41. That's how we will calculate the compensation part of it, right? Now what happens in acute respiratory acidosis? See, PCO2 will go up and bicarb will not get a chance to immediately start going up. So for every 10 units increase in PCO2, there will be only single unit increase in bicarb. So which means if PCO2 has gone up from say 40 to 50, the bicarb will only go from 24 to 25. Okay, so that's for acute respiratory acidosis. This one is for metabolic acidosis. Similar formulae for chronic respiratory acidosis is for every 3 unit increase in bicarb, for every 3 unit increase in carbon dioxide, you will have only single unit increase in. So see the change here? This, now the body has started compensating. Now acute respiratory alkalosis, patient is breathing faster, carbon dioxide is being lost, but since it is acute, so every 5 unit drop of carbon dioxide, there will be only a single unit drop in bicarb. But when it comes to chronic respiratory alkalosis, since the body has got time to compensate now, every 2 units drop in carbon dioxide will result in 1 unit drop in bicarb. So that's kind of, I have oversimplified them, but it is an approximation to the complex formulas, which is most of the time very close to the correction. So we need to remember these 6 compensation formulae, which we will be using a lot in our further discussions on ABG, and we will see how we'll see some practical problems also and try to solve them. Okay, so this is a very important stuff in interpreting an ABG, especially the compensation. Well, join me for the part 5. Thank you very much.